Alright, let's start by finding the x vertex using the formula, and the formula is x equals to minus b over 2a. So either we can use the formula x equals minus b over 2a, knowing that the quadratic function f of x is equal to ax squared plus bx plus c. So this is where we're getting the b and we're getting the a. So in this case it would be b is 16, therefore this is minus 16 over 2a, 2 times negative 2, which is negative 4. And negative by negative is positive, 16 by 4 is 4. This is the x coordinate of the vertex. To find the y coordinate of the vertex, we can find the f of 4. Therefore, we can substitute x equals 4 in the quadratic function and find the corresponding value of y. So in this case, it would be negative 2 times 4 squared plus 16 times 4 minus 26. Now this is 16 times negative 2, which is negative 32. 16 times negative 2 plus 4 times 16 is 64 minus 26, and of course 64 minus 32 is plus 32, and 32 minus 26 is just 6. So this would be the y coordinates of the vertex. It's y equals 6. Therefore you can plot the vertex for 6, which is somewhere here. Now, because the graph, the function has a negative a, every time we have an a less than 0, the graph would be concave down, right? So it's concave down, and therefore we end up with a maximum. So think about it, if the graph looks like this, then definitely we have a maximum. So the vertex for 6 is a maximum, and the graph should be looking like that. We have a y-intercept at x equals 0, y should be negative 26, so somewhere here it would be the graph. We can also, so this would be 4, 6 here. Now let me show you how to find the completing square, or how do I complete square. I can go over here. So let's go f of x equals negative 2x squared plus 16x minus 26. So the first thing I like to do here, I can take a negative 2 as common factor. So if I take negative 2 as common factor, this is x squared minus 8x, because I want to get back to plus 16, and negative 2 times negative 8 is plus 16. Again, I gotta get negative 26, so this would be plus 13, because negative 2 times 13 is negative 26. Now, I want to now change this and make a square bracket, because I want to try to change this x squared minus 8x to a complete square. And to do this, all I have to do is bring down the x, bring down the minus sign, divide 8 by 2, which is 4, square the whole thing, and always subtract the square of this number, which is 16, and then you have plus 13 here. So this is how we have to do the completing square. So always we need to complete the square of these two terms, x squared minus 8x. So you bring the x, you bring the minus sign, or whatever the operation here, whether it's a plus or a minus, you just bring it down. You divide the 8 by 2, right, which is 4, square the whole thing, right, and then always subtract the square of this number, which is 16 in this case, and then bring the 13, which is the last term. Now this becomes negative 2. Now we can do this, bring, remove the brackets, so it would be times x minus 4 quantity squared, and negative 16 plus 3, is negative 3, and if you multiply by negative 2, it would be plus 6. Compare this to the standard form, 8x minus h quantity squared plus k. So this is, we're done with the completing square, and you can check, you can go back and multiply, and you will see that you will come back to here. But again, the way I did this step to this step, I multiplied negative 2 by all this, negative 2 times x minus 4 quantity squared. I simplified, negative 16 plus 13 is negative 3, and negative 2 times negative 3 is plus 6, and that's how I got the plus 6. Now comparing this completing square quadratic function to the standard form, a times x minus h quantity squared plus k, where hk are the coordinates of the vertex, and if you compare, you get h becomes 4, k is 6, which is exactly what we got here. So you can find the vertex either by using the minus b over 2a formula for the x coordinate, or you can do the completing squares and get to the standard form of the equation, of the quadratic equation, and then this would be your h, this would be your k, which are the x coordinate and the y coordinate of the vertex.